messages can be matched? Answer. If receive type equal to send type and receive buff size equal to send buff size, then the message sent by Q can be successfully received by R. Of course, it can happen that one process is receiving messages from multiple processes and the receiving process doesn't know the order in which the other process will send the messages. What are the couple of points to be considered in connection with these wildcard arguments? Answer. A couple of points should be stressed in connection with these wildcard arguments. Only a receiver can use a wildcard argument. Senders must specify a process rank and a non-negative tag. Thus, MPI uses a push communication mechanism rather than a pull mechanism. There is no wildcard for communicator arguments. Both senders and receivers must always specify communicators. Write in brief the status P argument. Answer. Notice that a receiver can receive a message without knowing the amount of data in the message, the sender of the message, or the tag of the message. So, how can the receiver find out these values? Recall that the last argument to MPI receive has type MPI status underscore. The MPI type MPI status is a structure with at least the three members: MPI source, MPI tag, and MPI error. Suppose our program contains the definition MPI status, then after a call to MPI receive in which AND status is passed as the last argument, we can determine the sender and tag by examining the two members status.mpi underscore source, status.mpi underscore tag. What are the three approaches to consolidating data? Answer. MPI provides three basic approaches to consolidating data that might otherwise require multiple messages. The count argument to the various communication functions, derived data types, and MPI pack-unpack. We have already seen the count argument. It can be used to group contiguous array elements into a single message. Discuss one method for building derived data types, MPI pack or unpack. Define MPI derived data types. Answer. In MPI, a derived data type can be used to represent any collection of data items in memory by storing both the types of the items and their relative locations in memory. The idea here is that if a function that sends the data knows the type and the relative locations in memory of a collection of data items, it can collect the items from memory before they are sent. Similarly, a function that receives data can distribute the items into their correct destinations in memory.
Please subscribe our channel for more videos and education.